Hello everyone, today I am going to show how to convert C code Delannoy number into MIPS code. So first we start the program from main. So we put a label named main, and then here we can see there are two parameters ending on the function. So we initialize as 0, add immediate as 0, 0, 3. That means we initialize as 0 as 3, and 1, 0, 4. That means we initialize a1 as 4. Then we uh, initialize v0, 0, 0. v0 is v0. v0 is used for return parameter, so we are returning the result in v0. At initial stage v0 is 0. Then we call the function Delannoy and first exit. And now can we go to the function. There is a function. We put the level name, and then add immediate sp master. It is because we call JAL here, so the return address should be uh, initialized the address of this point. If we had a recursive function, the return address array would be reinitialized again and again, so the return address so we should keep this array in stack pointer register. We should also keep m, that means a0 and a1, in the stack pointer. So we have as we want to keep 3 parameters in the stack pointer, so we subtract 12. 3 into 4, that is 12 from the stack pointer value. Then we store world array 0 offset of sp, store world a0 4 offset of sp, store world a1 8 offset of sp. Then we check the condition m0 m equals 0. That means branch if equal 0 as 0 is base case. Then branch if equal 0 and 1 to the base case. Then we add as 0 if this condition, if a0 is not equal to 0, then it will skip this condition. Then check the n a1 is equal if it is equal to 0 or not. If it is not equal to 0, then it comes to the else condition. Then else condition, there are three recursive calls, So first we call m is my m minus 1 n, that means a0 minus 1 a1. So we add initialize, add immediate a0 minus 1, then we call the function again. Then if the function returns, we should load the a0 and a1 value. So we load the a1 value from the stack pointer. Then we load the RA register value from 0 offset of stack pointer. At last we add immediate stack pointer 12. So we subtract stack pointer 12, and now we add uh, to the stack pointer, add 12 to the value of the stack pointer, so that it remains the same, it go to the same position. There are more uh, functional recursive call in this stage, so uh, I should not write it here. I should write it the last of the recursive call. Then we go to the second recursive call. It we should subtract 1 from a1 and subtract 1 from a0. Then we call the function again. After returning the function, we should load the value of a1 and a0. So we load the value of a1 and a0 from stack pointer. Then we go to the third recursive call, that is a1 minus 1. Then we call again the function. After returning the function, we put a1 and a0 from the stack pointer. Then at last we put RA from the stack pointer, and then at last we add immediate sp12 to put sp pointer to the top. Then return RA. JR means return address. RA, return to RA. Then we write the base case. Base case level. In the base case level, we can see there is return 1. So we should return 1 after we load world array from sp. Load world a0 from sp. Load world a1 from sp. Then we add sp12, add immediate sp12. Then we add immediate v0 1. That means we are returning 1. v0 is the return parameter, so we are returning 1, and we add immediate to v0 is add immediate v0 1. Then we return it from here. Then we should write the exit level. There is a level named exit, so we should write the exit level and our code is done. Now, to run this we should save the file first. Save as and run assemble. If we run this code 3 and 4, the Delannoy number will come 129. Then if we run this code, the Delannoy number will come to V0. There we can see V0 is 0. After running, there is the V0, the value of V0 is 129. So that's all from now. Thank you very much for watching my videos.